Hello again. This is our day 2 lecture, official lecture. So continue on. This is actually the same day as our other lecture, but hopefully you can get this before. So this is being recorded on Wednesday for Thursday class. So hopefully you've had a chance to kind of go over this by the time we get to class tomorrow in the afternoon. Okay, so we're going to talk about today. Hopefully you have installed the Unity engine on your computer. You've installed WebGL build for it. You've installed Visual Studio. And so now you should be good to go with regards to working with Unity. So this is the Hello Unity lecture. Let's get my slides here. Okay, so let's talk again a little bit about the big coding picture. So games are made of rules and data. They have variables and functions. Functions act on variables. They take input. They have output. They work on things. They cause things to happen. They happen as a result of things, and so on. Now, in order to work, computers need syntax and semantics. Semantics. So you have to agree upon a structure for the language, agree to the structure and how you're going to communicate with it, and then also it's going to react to things based on the current state, right? So in the case, our little example here, the instructor is asking, well, what does surrender mean? And the student says, I give up. Now, the question is, do we understand what the student is saying? Gives up in terms of not knowing what surrender means? Or is he saying, I give up? That's what it means to surrender. So it's kind of a bit of a gray area. And the idea behind having syntax and semantics is to make things specific enough so that you understand the intent, you understand what's supposed to be going on. Computers are really rough that way. For the most part, you probably know that already, having taken Computer Science 1 uh, yes, computer science, and probably maybe even data structure, some other programs, other courses by now. You kind of get the gist of the importance of well-structured code and understand, kind of what's going on in different computer languages. So, for example, again here, syntax and semantics. We know when we parse a sentence as human beings, we say the cat sat on the mat. We know that that structure of the sentence actually consists of a noun, a verb, a preposition or object, or preposition and an object. So the cat is the noun, the is actually the article, but we get the subject of the sentence, the cat. The action that's being performed, sat, so the cat is doing the sitting because it's the subject of the sentence. The preposition tells it what or where things are going on, and then the what is actually the noun phrase, the object at that point, the mat. So the cat sat on the mat. We can understand what that sentence means because we know how the syntax of English sentences work. So, you're familiar with computer languages by now. You may not be familiar with working with game engines, though. Game engines are different. Their game engines aren't necessarily a language, right? They are a structure. They're a set of tools. Sometimes they have a language. Sometimes they even use multiple languages. Sometimes they have scripting. Sometimes they have, maybe they're made of C# or C++ or some language in general that allows you to have the actual source code to the engine in addition to being able to program in the engine via scripting. So engines themselves usually abstract a lot of the grunt work from development. Usually you're not coding things from scratch if you're using a game engine. Of course, you could have written your own game engine, in which case, yeah, you've done all the grunt work yourself. But for the purposes of this course, and usually in industry, you're using an engine that's already been developed. So we're going to be using the Unity engine, which has obviously already been developed. This allows us to often work at this sort of object and point and click level rather than at the coding level even, right? So we don't have to get down into all the nitty gritty, and sometimes we can even accomplish things without direct coding, without direct, kind of text-based coding. So it's kind of the best of all worlds, right? You can kind of pick and choose your battles. So you notice I've mentioned objects there. So objects, well, let's discuss them a bit. Now, these objects are not exactly object as in terms of object-oriented, but they're they're related. They're certainly objects in the sense that they are kind of self-contained structures that we're going to be working with, okay? So, in Unity and most other game engines, we're going to be working with game objects, and we're going to be using the techniques of object-oriented programming. So a game object is very much like an object in object-oriented programming. It consists of rules and data, right? They're combined and they're contained within a game object. Okay, it's a little bit fuzzy here. You'll have to stick with me a little bit. It's not quite as clear as that. A game object isn't a class in and of itself. It's not a structure in and of itself. It's a little bit different. It's more like a collection, but it's almost like an entity. Sometimes we refer to entity component systems. That's kind of one of the newer buzzwords as opposed to object component systems. But there are a couple of different models that get used in game engines this way. So let's think about it. Let's abstract this just a little bit for now. And pardon me, I'm going to turn down my volume level just a bit here, so I'm hopefully not clipping. So indulge me for a second. We'll say, okay, what are all the rules and data that might be associated with an individual kart in Mario Kart? Usually I would pause for your input back here, but in this case, since we are recording the lecture, I'm going to just kind of move on. So imagine we have a Mario Kart, a kart in Mario Kart. Now, the kart consists of all sorts of things that are going to be, properties and methods of the kart, right? So the kart has things like it has a position, it has a turning rate, it has a maximum speed, velocity, it has intersection boundaries, it has a sprite, it has images, maybe it actually consists of a 3D object, it has some kind of mesh, and so on. It has acceleration rates, the current item that the driver is holding, the angle, its rotation it's at, and so on. And it also has the ability to do things. It can brake, right? It can slow down, it can move forward, it can turn, it can display its mesh. It can play certain sounds, it can hit other carts, deploy items and skid and so on. So it is these rules and this data. Okay, so it is an object in general, but this is organized a little bit, even more compartmentalized and quantized a little bit further down as well. Okay, so in Unity and also in other languages as well, you're going to hear about these containers, kind of the object being used as a container for components. Okay, so components are really sort of the objects in terms of object-oriented programming. So a lot of the time, components are C# classes that inherit from monobehaviors. Now, if you're not sure what inheritance is, we'll get to that. That is one of the core tenets of object-oriented programming, that things can inherit from one another once you create things, so you can reuse code and so on. But we'll get into that a little bit later. Right now, let's just think of components as a smaller level object that makes up the kart and helps us to localize data and the data and rules kind of in a more concise way. So for example, in the kart, we might have a transform component that consists of the position, the angle, the size, or the scale of the kart. Okay, so that makes sense for those things to be together and to have a common set of functionality around them. So you might scale or rotate or reposition or move objects. So it's nice to be able to have those functions on a standardized component called a transform. Okay, so the kart game object has on it a component called a transform. It also will have a component called a sprite renderer. And the sprite renderer will have a sprite image, and it also will have the functionality built into it to know how to display that image. Okay, so it's not just data, as in the case of the transform. This one actually has some rules to it as well. So it has some code. It's going to be, in our case, it's going to be some C# scripting in there that can take advantage of. And some other ones with components like a rigid body 2D, which takes care of a lot of the physics. Right, the intersections, the boundaries, the velocities, what happens when it hits another kart, perhaps, or maybe it works in conjunction with other components like colliders, in addition to rigid body 2Ds, and they can cooperate and work together as well. Then we might have another component like the drive mechanics, so that might establish what the maximum speed of the kart is, what the acceleration rate, the turning rate is, and so on, and also the actions that you can perform, like braking, skidding, move forward, and so on. And then another component might be the item manager, the inventory manager that's associated with the kart, which is, what's the current item that the player has that the player could throw? Can it be deployed? Does it play a sound? And so on. Okay, so this is how we're kind of breaking things down into components. Now, in game development, you're going to hear about certain common components, like things like colliders and rigid bodies, and controllers. Okay, there's a lot of the jargon and lingo that go along with game engines, right? So normally when we have a player in the game or the hero in the game, that will have some sort of controller that allows us, as the user or the player of the game, to control the player, right? So we're going to hear about that later. They might also have a component that might be the game manager, which might manage certain aspects of the game, or manage certain states and so on. Okay, so there's going to be a lot of common terminology you're going to hear across a lot of different games, and they're going to be largely at this sort of level. All right. So let's talk about specifically in Unity how things are sort of organized. All right. So in Unity you have game objects, which are not exactly the highest level of the hierarchy. Scenes are really the highest level of the hierarchy, but game objects are kind of the objects within the scene or the current state. So the game objects are sort of the things, the standalone objects in the scene. They're the nouns. They are independent objects, and they can be on screen or off screen. That's not, they're sort of in the world. For example, the cart, right? And then you have functions that can be performed. The functions are ultimately the rules, the verbs, and they are contained within components that are placed on or associated with the game objects. Okay, so those functions within a component might be the things like moving, flying, wrapping around, blocking, aiming, and so on. Now, also as part of the component, you're going to have data in the component. And the data in the component are the properties, right? The data, the adjectives that are contained within. So it might be location, position, health, rotation, ammunition, different directions, physics qualities, and so on. All of those sort of properties. Okay, so they're within components as well. So components are made up of those functions and properties. They are C# classes. Okay, you've hopefully heard of classes before. Okay. So the components, there they are. They are containers that group related functions and properties. You add them to game objects, and there are common ones that already exist, that have already been written for you, that are just sort of part of the engine. Transforms, sprite renderers, colliders, and so on, right? They already exist. There's also going to be certain events that can happen in the game engine, and the game engine can often manage events for you, or sometimes you're going to write your own sort of event management. So events are sort of conditions or circumstances that we care about for a particular rule, and it often applies a function to a property on a component on a game object, right? So it sets up this kind of hierarchy of things happening. So you might have a collision event that's going to then call the collision function, that is going to manipulate properties within some component on a game object and may trigger it on others, and so on. So for example, like when a button is pushed, when two objects touch on every frame and every second, those are sort of events that happen over and over and over again that we need to respond to and work with. Okay, so examples, we can like see them in this case, lay them out as, look at our objects with their functions, their properties, components, events. So the event might be if the D key is pressed, then the player moves to the right, which is changing position on the transform. Okay, so that's the use of the player controller. The player controller might be manipulating these things. Okay, you might have another thing where every frame, all the ships on the screen move towards the player's position on the player's transform. Okay, so there's another situation. So what if there's a collision between a plasma bolt? Okay, the plasma bolt is the object, the collision is the event, and one of the components is a collider on another object's collider. So we have the plasma bolt's collider, the enemy ship's collider, two objects and two components on those objects interacting. That might cause a decrease in the health of the ship, possibly within some sort of ship control component or within the player controller and so on. All right, so whenever the health of the enemy ship control reaches 0, destroy the ship, spawn an explosion, play an explosion sound on its audio source, etc., etc., etc. Right? These expressions, these functions, these methods can be as complex as you need them to be. Okay. All right. So now we're a little bit of a background in terms of why we like to use object-oriented programming in game development, and a little bit about, in the case of Unity at least, how these concepts map onto the game engine and what it does for you as opposed to what you have to do for it. So we're faced with a conundrum. So sort of a crossroads, we say, okay, which can we tackle first? Do we talk about Unity concepts first, or do we talk about programming concepts first? Do we really learn the C# language learn everything we can about it, and then we learn about the Unity engine, that would be no fun. And vice versa, because we can't really just learn everything about the Unity engine and then learn about C# when we're done either. So I ask that you buckle up and focus on the concepts, at least for today. Okay, as we get into things, it'll become more obvious. Everything will become more fluid to you. You'll become more versed in, the day-to-day activities that you're going to be doing inside of Unity. All right. So here we are. Here's a quick view into Unity, or into the Unity editor. And this is a slightly older version. This is Unity 2019.2. Your screen may certainly look different than this. One of the things you can do is you can customize Unity's window layout to have your like. What particular views you like to see. Where do you like to have your hierarchy versus your project versus your inspector and that sort of thing. Do you have the scene visible while you're looking at the game view and back and forth and so on? Who knows? You can decide all those things. So within Unity is where you're doing all of the sort of building and layout, the pointing, the clicking, the setting of attributes and things, all within this sort of very WYSI. What you see is whatever. It's the GUI. It's the graphical user interface, or the integrated development environment. All right. And we're going to see one other level of hierarchy here. We talked a little bit about it in class, this notion of scenes. So scenes is sort of one of the upper level. The only thing above scenes, I suppose, is the project itself. But really, as you organize things, you can use any number of different scenes that you want in the game. And we're going to have different scenes that represent our different projects within our game. So we're going to have a number of them right away. Sometimes we put off learning about scenes a little later, but we're going to kind of try to deal with them more up front here. Right, so in this game we have a level 1 and we have a you lose. So maybe there's a wah wah wah, that scene that happens after the player dies or something like that. Okay. So we see a lot of the things that are in the screen here, and the Unity interface is made up of these different panes, and most game engines have them. If you're familiar with Unreal, it also has a pane-based system like this. But we're looking at Unity after all, so we'll stick with that. All right, so generally, here's the hierarchy. We talked that there are scenes, and the scene is going to contain everything that's in the world at the moment, and it's contain objects within the scene, and then components are on those objects, and those components are largely made of scripts. Okay, generally components are scripts, right? The ones that you write, the custom ones, are almost exclusively scripts. So you can kind of think of them, think of any component as basically sort of exposing here in the inspector window, is going to expose certain things about that component. When it's an entirely custom component, you're even going to see an access to the script that is driving that component. Okay, so here we have our hierarchy. So this is our hierarchy window, which is showing us everything that's in the current scene or currently in the world. And this is just a sample scene with a camera in it. And this is the only object in the scene is this camera. This is what starts off when you just go into a blank Unity project. Usually you'll have a camera. The camera will have a transform. Every object has a transform, the transform being its position in the world, its rotation, so its orientation. It has a position and an orientation. So position is this place in space. The orientation is its rotation, or where it's facing, sort of thing. Imagine having you can move anything around in the world. So you can move it to a certain position, and then you can rotate it in any direction. Okay, and you can also have a scale for that object as well. So we can scale it up, down, in X, Y, and Z. Now you'll notice, even though we're working on a 2D game for starters here, that we also always have a Z. We have X and Y in 2D, but we also always have Z. Z is always there. Unity is inherently a 3D system, but we can sort of ignore or collapse Z down. Now, the one thing to be careful of, though, is that you'll notice here the main camera is at location -10. Okay? What that means is that it is not on the same plane. It is actually back from the plane that the game lives on. And that's because the camera has to be able to observe the game. So it has to look at it from a certain vantage point. Carl Sagan did a really interesting talk about flatlanders and the whole ability of someone to perceive in 3D. So if you have a 2D entity kind of living on a plane versus a 3D entity living in a 3D volume, it's that separation that allows one to perceive the other. So it's important here. I'm diverging a little bit or digressing a little bit here. The important thing is to remember, though, that your 2D objects, you're going to want to have them at z equals 0, and your camera, for now, you want to be at z at minus 10, so that it is offset from the screen. And we're going to want it to be rotated to 0, 0, 0 so that it faces this plane in the scene. We'll talk a little bit more about that later as well. Okay, so this is our main empty scene. All right, so we have the camera, and I talked a little bit about this transform component, right? So over here in the inspector, we're normally seeing the components on that game object, the transform being the one that everyone has. And you'll see here that the camera, it's called main camera, but it's actually just a game object that happens to have a camera component on it. Okay, so it's a camera component, it has a transform component, and it also has this thing called an audio listener. Right, the audio listener allows audio to be basically where the audio is being observed from. So if you have three-dimensional or spatialized audio, you want it to be observed from or observed as if it was the camera that had the ears, right? So that's why in this case the audio listener is on the camera, right? So audio is being observed from that position, just like the image is being observed from that position as well. Okay, so we covered a couple of things here about the cameras, audio listeners. You can think of the audio listener sort of as a microphone, in addition to the camera there, okay? And they are components of this main camera object, this game object that happens to be called the main camera, okay? So that's the normal things in the scene there, the scene view. I mentioned this also in one of our other lectures, that there's sort of this two-part dichotomy in the Unity world, right? You have the scene, you have the objects that are in the world, and then you have this GUI, this canvas, this heads-up display that sits sort of outside of the world. It's this special interface and these special interface objects that are placed on this thing called a canvas. And from that we can get user input. We can do things like, allow buttons to be clicked on or text to be input and that sort of thing. And this canvas has a very special relationship with the camera. Typically, the canvas is overlaid on top of the camera. So no matter where the camera moves, no matter how the camera is scaled, the GUI, the HUD, the canvas, stays in the same position with regards to the camera. Again, it's sort of like, imagine you're Tony Stark and you're in the Iron Man suit, right? And you have your heads-up display, so no matter where you go, no matter what you look at, you get that heads-up display of what's going on in the world according to that heads-up display. Right, that's what the GUI Canvas GUI system is doing for you. But Unity's GUI input system. There. All right. So what else? Oh, well, one more thing. Let's talk about sound just a little bit. Now, I'm a big fan of talking about sound up front because a lot of times it's easy to sort of ignore sound, and I come from a background where did a lot with interactive music and things, and I think sound is a very, very, very important part of the experience. So let's talk a little bit about sound. So in this scene, you can see what's happened is there is the main camera, but we've also created something called an audio source. So there's an object in the scene called an audio source. And an audio source is going to be something that emits sound. Okay? We place an audio object in the scene, an audio source, and it's going to have this audio source component on it, which will be able to play an audio clip. An audio clip will generally be a WAV file. So this audio source will play a WAV file as if it was playing at that location, and then it is perceived by or kind of spatialized by the listener that was on that main camera. Okay, so our first project, we're going to be using the canvas, the GUI, and some sounds. We might use a little bit, in this case, we're letting people use a little bit more of the other built-in objects as well to make life slightly easier than we usually do as well. So, what else do we have? All right, so we've seen the things, we've seen the scene, we've seen the properties. What else? Okay, well, In the Unity editor, another important part is this thing called the project. That's when you first created, and you'll notice at the bottom of the window there, all of the stuff in your project is kept in the project here as a folder. And you can find that folder actually on your disk. When you do create a project, that's where everything lives. Usually the things that you create are going to be created as assets and put in this asset folder. Within assets, you'll immediately see it's already created a scene folder for you, and it has your scenes in there. Now, it's up to you with regards to how organized you want to be. Unity will actually go and search through everything in that folder for you. So if you can put scripts in with sounds in with images in with whatever, you can like arrange them all over the place and be as messy as you like, and Unity will generally still find things. Okay, it can lead to certain unintended behaviors, so you want to be careful about that. And especially when you are looking something that, if I am helping you debug a problem or I'm grading based on your quality of your code and your organization, it is important to be organized, right? A messy project is going to be easier to maintain. It's going to be easier to develop. Did I say messy? A well-organized project is going to be easier to maintain and to be developed than a messy one. I don't know if I got that right. I'm not going from a script here. So, all right. So the stuff in your project is kept within this project pane in the asset folder, but you will see there are other packages that you might load. We can load packages from the asset store, and sometimes I may provide packages as part of this class that you can then install into your projects to do certain things. We'll see how that goes. All right, next, scripts. Now, scripts are the one big thing that is not handled. You can view them a little bit inside of the Unity editor, but largely they are going to be handled outside of the Unity editor. You're going to double click on them and you wind up in your Visual Studio. And this is an older version. This is Visual Studio 2017 for the Mac. I warned you, once upon a time I was more a Mac user, but now more a Windows user. So your Visual Studio, odds are, will look quite different than this. But this is where we're going to be doing our coding, our debugging, and yeah, there's going to be where our typing is. Now, I'm going to go over this real quickly. This is a kind of a generic looking script here. Whenever you create a script, Unity is going to create a generic class for you. It's going to be based on the name of the script, the name of the file that you create. So in this case, I created something called master.cs. All C# files are called .cs files in Unity. And that name of that file is going to match the name of the class. The object that you're creating, this class, has to match that. And all normal Unity objects, Unity components inherit from this thing called a monobehavior. So when you create a script, this is its template that it uses. And it's even going to put in some sample or some stub functions here for you for start and update, which you may or may not use. But there's some examples of things that you typically use. Some sort of initialization code that might go on in your start routine. And then update is something that happens over and over and over again in real time during your game. Okay. So let's talk about script a little bit. So now you know where script goes and sort of what it was. This is maybe obvious to everybody in here. Again, usually sometimes this is a no programming experience required course, so we start at the very beginning. So traditionally you always start with hello world and printing hello world, and certainly you can do that. This works in Unity. There is a print hello world. Okay. Unity does have a built-in function to output text to the console. Unity has a console window inside of the editor that'll help you with sort of online debugging. You're not using the debugger, you're just using sort of print-based debugging. It's not something you'd actually use in your game. The users are not going to see the console. They shouldn't see the console at least, but you're going to use the console to print things out. So you can put print hello world, it will print it from your script into the console. All right, so here's a built-in function. The parentheses around that function tell you, and they're always in pairs, they execute the function and contain the data that the function needs to do its thing. In this case, the text that we're going to output, which is the hello world, is the argument. That's the data that we pass into it. The print function expects this to be a string. Okay, a lot of time it will do conversions. It will cast things and turn them into strings for you, depending on how you write your code. But print is expecting it to generally to be a string. All lines end with a semicolon. Tells the compiler we have reached the end of the command. Right. So this is the most basic, one of the most basic functions, most basic syntax pieces in C#. Looks very much like C++ or good old-fashioned C. Now, one thing worth mentioning. Print in Unity is actually a shorthand for debug.log. It's really meant for debug logging, or logging information about kind of the game state internally. It's not meant to be used as print, print to the screen or anything like that. It is really just a shorthand for a debug logging statement. Okay. So let's talk about the next big step. Okay, so we have, on the one hand, we have the component system, and then we have our script. We have objects, and we have scripts. How do the two meet? How do they get together? How do they actually work together? How do we get them to work as a unit? Well, the best way to do that is to give it a try, to show what's what. All right, so I'm going to dive into that a little bit, and we're going to do this inside the context of, we're going to sort of be Project One a little bit. Okay, so Project One is inspired by a game I like to call the No Video video game. And this was a Real Sound. It was called Real Sound, and it was a game by Kenji Eno and Warp, done for the Sega Dreamcast. And it was literally a video game that had no graphics at all. It was entirely played by sound. So I get some inspiration for that. Now, we're not going to do no video. We're going to actually have text, and maybe we'll even diverge from that a little bit, but that's sort of the inspiration behind this game here, to sort of challenge ourselves to learn about the audio and learn about the UI without getting bogged down in the text, right? So that's where we're going to be. So homework 1 concepts. We're going to have some simple things. We're going to create a D-pad, a virtual D-pad for input. We're going to have some sort of action button, and maybe the action that you're going to do is turn a flashlight on and off, or maybe you're going to echolocate. So you can, like, say, ping the world to figure out where you are, how close are you to a wall or something like that. You're going to have some text input, and maybe you have a volume slider, things like that. You can have a little bit of room in here to try things out. And for output, we're going to be using things like sound. So maybe there's going to be triggered sound that happened as a result of bumping into a wall or reaching your goal and so on. There's going to be some description boxes, or just text that will show on the screen. Most of your interaction between you and the user is going to be through text. We're going to have output somehow to indicate to the user what the user's progress is, if they're running out of time or they're taking too many turns, or what their score is, and so on. Are they getting hot versus cold, closer versus further? Are they hearing it louder versus softer? So we're going to always be kind of balancing the modalities so that people can, kind of figure out what's going on. Have they reached a dead end, and so on, so on, so on, so on. All right. So there's a lot of text on here. I'll leave this aside. This is sort of like the real rundown, the design of the project. But let's exit this for the moment now. Leave this here. You do have access to this in LMS if you want to see everything here. So let's jump over to Unity and take a look at a little prototype for this game. All right, so first things first, what I would like you to do in your game is eventually you're going to want to have a scene, which is going to be your menu scene, which is going to have a set of buttons. These are just 4 buttons there, actually 5 buttons, one for the About button, and some text in this scene here. And if we look over in the hierarchy, and I'll go ahead and blow this up so we can take advantage of all the real estate on the screen. So we can see that we have a main camera. We have something called a scene manager. And the scene manager is an object I created that all it does is it includes this stage manager script, which is the thing that contains the code to go back and forth between different objects here, right? And then on the canvas is where the buttons live. So if you want to add a button to the canvas, you click and say, okay, UI button, and we'll use this, and we'll kind of be able to move it around, and we'll put this down here. And this button, we're going to call something special. So let's change the name of that button to demo. This is our demo button, right? You notice the name didn't change because the name is actually part of this text component in here. So demo, and we'll call this, we'll put on the button, press me. Okay, so I've created yet another button called demo, which is a game object, which automatically has a number of different components on it that do things like show an image, run the script that actually clicks the button, and actually render text as part of the button. Okay, so I've placed that object there, and I want to have that button do something. All right, so imagine I wanted to print something to the console. We had our print message there. So I want to print something. So I'm going to create a script. So I'll come down here and I will say, okay, I'm going to create a script, and that script will be a C# script. I can do that directly there. And we will call it what? We will call it demo. That is our demo script. If I double click on that, it will open up the demo.cs inside Visual Studio here. And you'll see it has started a class called demo. I should have named this better. I should name this demo, capital demo. And I should also, let's see, because classes should be named with capital letters. All right. And this script here, let's see, can I rename it right there? Rename demo. Okay, to get this to work, for Unity to be happy, it has to match exactly. Demo and demo, they have to match. Okay, and I'm going to get rid of my start and update functions in here because I'm not going to worry about those just yet. Okay, I'm just going to have a print me function, and print me is going to be a void function, but I'm going to need to use this. I'm going to trigger this from other things. Now, something in C# that we're going to have to know about is we have this concept of private, public, and protected members of the class here, of the things. So you'll notice immediately that it made this class public, meaning everybody can see it. And what I'm also going to need to do is I'm going to create it so that this function in here, this print me function that I want to create, okay, that I'm also going to make public, because I'm going to use that from the Unity editor. It's not going to be something that is hidden inside the editor. Excuse me, hidden inside this class. Now you've also see that it is saying, naming rule violation. These words must begin with uppercase characters. Print me. Show potential changes. That's a good idea. So it should be called print me. Okay, it doesn't have to be, but it should be. So show potential. Okay, so we fixed that. So normally classes and functions or methods, we want to have them kind of capital camel case, right? Anything that is a type or a class type or a method, we want to have capital for the first thing. If it was just data, then it would be lowercase. So the print me function, okay, print hello world. There we go. Control save. All right, we have written a script. It is this demo class, and it has a print me method in here, and it's going to print hello world to the console. So, okay, let's go back to Unity. So here it is down here, demo, and hopefully it should have fixed its name by now. Let's see. Let's assume that it has. And double check here, just for good measure. So we need to call that. We want to call that by pressing this button. Now, a component like this, a script, can't just live on its own. It has to be put on an object. And it could actually be on any object in here, but we're going to go ahead and, for the heck of it, we're going to put this script directly on this demo object. And how do we do that? Well, if we select the demo object that makes up that button, we can say drag this demo directly over to there. And now that we've put that script right on there. Okay. And now let's make it so that we can call that action, because right now if I just hit play, nothing's going to happen. Here's the console up here, nothing is being there, and if I click that, nothing happens. Okay, so stop that. It's important you go into play mode up here when you test things out. Don't edit things when you're in play mode. If you edit things in the Unity editor when you're in play mode, they will be undone when you stop the Unity editor, so you'll be dropped back out, and that'll ruin your day if you did lots of stuff in there. So we won't do that. So okay, back to demo. Now you'll see the demo script is there. Let's go to the button. So the button is the important thing. The button is actually what's going to control when things happen, how this responds to that click event. You'll see even here there's this part of this button script that has this on-click event. And what we want to do is we want to call our code in reaction to that on-click event. So go here, we'll say, all right, let's add our function to that list. So we'll say plus, and now we can say the object that this lives on. We're going to come over here, click on scene, and you may be seeing this like this. We don't want that. Go all the way down small. So crank that all the way over there. And let's look for the object that has it on there. Demo. That's the one that has the script on there. Okay. So the demo object, and now we can drop this down and say, okay, there's the demo script. And here's this function, print me. Okay, so on click, the print me method within the demo class will get run. All right. Let's see. Let's assume that is a bug. Sometimes you'll see errors in here that are related to Unity trying to go for the asset store or make a network connection, things like that. Let's hope that wasn't where that came from. So actually, hopefully that was where it came from. Okay, so I press play. My game is now running again. I'm going to click press me. And over here, you'll see in the console window that you have gotten hello world happening, okay, in the debugger there, right? If I say collapse, it will collapse those all and say, I've pressed it 12 times, 13, and so on. It's a nice thing that it will do that. And we'll uncollapse it. Print me, print me, print me. So that's happening all the time. Right, so congratulations, you've written your first script. Now, we will talk a little bit about the script manager in a next lecture or a next video. I'm not going to get too much into that. So for now, if you want, and you want to just have things react in response to that, to a button, you can go ahead, I'm going to say for now, create a distinct scene called adventure. And we'll open that up. We'll say save our other scene. And the adventure scene is our game. Okay. So hopefully now, the way that Unity is working, hopefully OBS will capture the sound here. So you'll see I have a text area that's going to explain to the user sort of what's going on. And I have my directional pad here, north, south, east, west, and east. And then I have my action button here, my flashlight. So I'm using this as the thing. So if the flashlight is turned on, I can see my little RPI logo here. Now the RPI logo is my player, right? So here's my player. And the player, in this case, has a player controller script on it. Okay. None of the other objects in the scene, the canvas, the buttons, and so on, none of them have any scripts on them. There's only a single script in this scene. So if I go to my scripts folder, you will see there is the player controller script. Okay. So I created an empty object. I just said 2D object, and it could be anything or just empty. And that's going to put an empty object in my scene. So let's just put it right here in the center, for example. And then I can put components on that object. I'm going to go ahead and undo that. All right. So we'll go back. Here we are in our scene. And now I'm going to enable it again. So I've got this code running. So the buttons. See, you should be hearing that, right? Okay. So, I just used up all my flashlight battery. So you see battery level is at 0. No matter what happens here, I can't turn that back on. And I've already done 40 moves Well, moves are, I get a penalty. If I move with the flashlight turned on, it counts as 2 moves. All right. So I'm moving around here, and you'll see up here I'm using print to tell you what my position in the world is. Okay, so I'm moving an object around in the world according to these buttons that are pressed. And I'm not going to explain every piece of it along. This is really just to set the stage for the project now. And you'll see this text is changing up here saying, you were in a quiet place, meaning I'm probably in the middle of nowhere here. I'm going to cheat. I'm going to turn on the sprite render. Okay, there's where I am in the world. I'll turn it back. The moment I start walking in, it's going to turn it off again. So I'm in a quiet place. I feel no different. Nothing is really going on. Suddenly I feel warmer. So I want to feel warm. That's where I want to go. I'm going to keep clicking. You'll see, no different means I'm not warmer. Oh, I'm getting colder. I'm moving away from the object. So I want to go warmer, warmer, warmer. Follow that. Oh, I guess I hit the wall. All right, let's wander around here a little bit. Warmer. Warmer, warmer. I hit a wall, but I am now carrying a key. And if we looked carefully, you may have seen it said, you find a warm key, which is telling us, okay, why it was warmer and colder. I don't know. It's a little bit of narrative in there. But anyway, so I have now found the key. And now I'm going to wander around a little bit more. And you'll see it's incrementing my number of moves here. And I happen to know, I hear an ocean, and it gets louder in the distance. And you'll see it's also telling me softer versus louder. And I'm gonna talk really loud. I'm gonna I'll turn down my game audio a little bit here. And it's softer again, louder.
Yay!
Okay. Okay. So I have a little bit of audio in there that says, okay, when I actually get to the door, you see, okay, you hear an ocean through a locked door. You unlock the door and escaped. You're still carrying the key. Okay, so I've reached the end. Now, normally this should also pop you back, or it'll stop here and then maybe show you a different button to say return to main menu. You might have something like that. Okay. So these buttons are being triggered, or being used just like that other button I just showed you. Okay, they are all triggering code on this player object within its controller here. Right, so if I look at any of those buttons, I'll stop the game, go to the hierarchy, click on them. You'll see onClick is using the player, and it is calling the player controller myMove function within that player there. Okay, so that's how that is working. And it is also passing it a value. So if I look at the south one, you'll see it's passing a value of 2, west is passing a value of 1, east is passing a value of 3. So it can tell what direction I'm moving in. So let's take a quick look at that script. So I'm going to go to my player, which I've dragged that component on. You can also, if you want to create a component from scratch, you can always say, new script. So you don't have to create it ahead of time and drag it on. You can just add it to the object here using the add component, but we already have it there. So if I double click on there, you see my script. And in here, it's got some lines of code, but it's not all that complex. The logic in here is largely if-else sort of logic. There's a little bit of setup in my start routine. There's a little bit of kind of standard logic that gets set up, or standard variables that get set up in terms of, the data contained within the class. There are some references to other objects in the game. So you may have noticed up in here, this ocean, key, flashlight, sense, and score. These are other objects in the scene. And I set them by actually dragging them. So for example, I could drag score and put that there. So now this script knows how to call the score object through that reference. Okay. Let's hop back to there. So I set this up by saying, that is a public field, or a public a variable inside this class. There is no update, so nothing is happening once per frame. This is a turn-based game, right? So it's really time changes only in reaction to moves. Okay, so my move is really where just about all of the action happens. So my move consists of 3 parts. Um, it consists of the part where we figure out first, how am I going to change the position of a game object according to the past value, which is going to be either 0, 1, 2, or 3, which we have mapped to using an enum to WASD, or WS, A, and D. Then the second thing it does, whoops, I really messed up my code. So the first thing it does is tries to move that player. Then it checks to see if that position is valid, right? So it says, okay, try to move, and then if it's not a valid move, I'm going to hit the wall. I'm going to go ahead and tell the player to hit the wall and play that sound. And next thing it does is it clamps that to make sure you didn't actually move outside. So you're limited in your movement. You're limited to moving inside of that room. And then it does any logic there. It does have one other function called use flashlight, which is going to be what determines how the flashlight is used within the game. Then there are 2 other components. There are blocks of code here, and our scope is through these curly braces here. So the first, it's kind of arbitrarily, I've just used this as just a scope indicator here. There's the management of the ocean, this ocean piece of things, right? So it's text, am I near my ocean sound? And if I'm on top of it, what do I do? Or as I'm moving, how does that affect the volume? As I'm doing my ambient sound in here. And then the second piece is finding out about the key. So I'm checking how far am I from my current position to that key's position. Do I already have the key? If I don't already have the key, then I should say, okay, am I getting warmer or colder based on getting closer or further away from the key, and so on. Okay, so that part. And then last but not least, I do some score tracking, and I just said, okay, let the player know every time you take a move, it's going to add 1 to the score and print it to the screen. And also up here, where's my penalty? Said, okay, oh no, the penalty is down here in the flashlight. So here's if the flashlight is being used, if the flashlight is turned on and there's batteries to be used, it allows the flashlight to stay on. And I increment the score and I give you the penalty there, and I also subtract from the battery. Okay. So that's a real, don't expect you to be able to just like run out and from this code or from what I've kind of shown you so far, finish the project over the weekend. We're not quite there yet, but this is just to kind of set the tone for what the first project's going to look like, and also kind of let you know what the key components are that you're going to be interested in. So be looking for, your GUI elements. You're going to be looking for your audio sources and manipulating the volume. You're going to be handling some very, very simple printing through by setting the text fields within buttons or setting the text fields within your text objects. So pretty straightforward stuff. We're going to do a little bit of scene management and so on, but hopefully this kind of sets the stage for you. No idea how much time that was, so hopefully this wasn't too much to digest. Almost an hour's worth. Wow. Okay. So tomorrow's lecture will be a short one based on this. Largely questions and answers. We'll kind of go over the code maybe interactively and see, get a little bit more of a feel for it. All right. So make sure you've downloaded Unity. Try things out. Follow along. Look for those different objects. Try to insert things in your scene. Design some things. Put some buttons. Attach some code to it. Maybe even type in a few simple scripts. Until next time, take care.